Hello, Algebra 2. Got a couple more topics for us to look at before our final. Just a very few. Today, we're looking at more factoring methods. Oh, I know, back to factoring. But these are some important skills to solve similar problems to the ones we've been doing without synthetic division. Now, if you remember most of the problems I've been giving you with synthetic division, and to find x-intercepts, I've always given you sort of the first x-intercept. I've always given you a little bit of info. Like on the ones we've been doing, oops, not those, these ones, you got to look at a graph and you got to see a few of the easy x-intercepts, and so you now know what to start your synthetic division with, right? That one, I know what to start that synthetic division with. But what if I gave you this question without the graph? How could you start to do that? Well, that's where some factoring techniques can come into play and help us out. So, we're going to use these factoring techniques again to find some x-intercepts. So the first type of factoring technique that I want us to go back towards is the greatest common factor. So letter A right here. We have this cubic, x cubed minus 4x squared minus 5x, but no graph. So if I wanted to graph this, where would I even start? Well, thankfully, this is a bit of a simple one, and so if we look at this, we notice that there is a greatest common factor in all of them. These three terms all have an x, so I can factor out the x. All right, I just pulled out an x from each term. They all had that x in common. So we pull out the x. How many x's are left? Now here I've got an x squared, because cubics, taking out one of these x's, you're left with 2, minus a 4x. We took from a squared, we took one of them out, we're left with 1. And then the last term, if we take this x out, there are no x's left, so it's just a 5. Well, now in the parentheses here, we've got a quadratic. We know how to factor quadratics. What multiplies to be 5, or sorry, negative 5, and adds to be a negative 4. Hopefully 1 and 5 will do it for us, and it does. 1 and negative 5. Thankfully, this is a nice simple one, so we don't have to use the box. Because the a value is 1, we don't have to do a more complicated factoring. This is just x plus 1 and x minus 5 with that x in the front. And so if I want my x-intercepts, I can now see them all because I have factored form. This first one is 0. The second one is negative 1. And the third one is 5. And so if I want to draw a quick sketch of this graph, I now can. I know it goes through 0. I know it goes through negative 1. And positive 5 will be out here somewhere. And it's a cubic with a positive a value, so I know the end behavior is going to go there and there. So I know it must come up that way, and then up like that. So there we have it. We were able to find the x-intercepts from a cubic if we are lucky enough to have that greatest common factor. Now, that's just a skill that I'd like you to get good at, and so B and C here are simply more practice, but they don't exactly have all the context and the graphing like these do. So, part B, take a look. What do these two have in common? I can take out a 3 from both. How many y's we got? And they each have a y cubed in common. Once we pull that 3y cubed out, what's left over? Well, 3 divided by 3 is 1. And if I pull out 3 y's, they are left with 2. And no, you don't really need the 1 there in front either, do we? So I'll erase that 1. All right, minus 48 divided by 3 is, what do we have there? 3 goes into 4 one time with 1 remainder. 3 goes into 18 6 times. All right, how many y's are going to be left over? Well, if I took out 3 and there were only 3 to begin with, that means we won't have any y's at all. So we factored out the GCF there. All right, let's do our last one here. What do all these have in common? Well, we can divide them all by 5. How many z's? Z squareds. So I can pull out a z squared from all of these. All right, that means I'm just going to have a z squared at first. A 30z divided by 5 is a 6z. There's 1 z left over. And the last one plus 9. Can we keep going with the factoring? I think we can. 3 and 3 add to be 6 and multiply to be 9. So that is 5z squared times z plus 3 times another z plus 3. And if you wanted to write that as a z plus 3 squared, you certainly could. So that's the skill there. And sometimes, as in letter A, it helps us find x-intercepts, and it helps us graph. All right, one more factoring method I would like us to be able to use to that end. And it's actually an oldie but a goodie, factoring by grouping. Now before, this helped us factor a trinomial with x squareds. But now it's also going to help us do x cubes as well. So pause if you need to write these down. I'm going to show you how we can use factor by grouping to factor these cubics. All right, and it starts off the same. You divide your problem in half. So on the left, I'm going to factor out the GCF. So we've got x squared in common for both of them. We've got 3 of them there. We've got 2 of them there, so I can pull out a total of x squared out of both of these. I'll be left with an x right there. All the x squareds are coming out from the second one, so that will just be x squared plus 5. Now do the same thing on the right side. So what do these two have in common? Well, I can take a 4 out of both of them, and I see they're both negative, so I'm going to take out a negative 4 from both of these. So that will be a positive x left over right here. Negative 4 divided by 4 is positive 1. Negative 20 divided by negative 4 is positive 5. And what do you know? The parentheses are the same. And so we can pull out these entire parentheses, just like we used to do in factor by grouping. So x plus 5 comes out to the front. Now what is left over once you pull out the x plus 5? An x squared and a minus 4. And that is all equal to f of x. Remember, our goal here is to get our our x-intercepts. One of them you can see just fine, but we can keep factoring. That right here is a difference of squares. And so I'm hoping you can remember x squared minus 4 is x plus 2, x minus 2. All right, that right there is a quick reminder, is a difference of squares. And so now we have our 3 factors, and now we can get our 3 x-intercepts. Negative 5. This one gives you negative 2, and this one gives you positive 2. And so we can draw a quick sketch. Let's see, negative 5 way over here. Negative 2 would be what, about right there? And then positive 2 would be about right there. And so we know our cubic, that's a terrible drawing, but hopefully you're with me, looks something like that. All right. I'm going to skip this one. This one works exactly the same. Maybe pause the video and see if you can get that one on your own. But I'm going to come down to a slightly harder one just for the sake of time. All right. This one works out just almost exactly the same as the one we just did. But let's do a harder one. So I cut that in half, factor the left. Let's see, I can divide them both by a 2 and an x squared, it looks like. So that will be an x minus 5. On this side, I can factor out a 2. And if I do that, it'll be an x minus 5. Oh, the x minus 5's come out. And I'm left with a 2x squared plus 2. All right, where are my x-intercepts? Well, this one is easy. That one's 5. But this one, not much to do there, is there? So what we have to do is set it equal to 0. 2x squared plus 2 is equal to 0. Minus 2 minus 2. 2x squared is equal to negative 2. Some of you might be seeing what's happening here, huh? This should be looking familiar. We get x squared is equal to negative 1. We square root both sides. And that imaginary number rears its head again. X is equal to I or negative I, right? We got to do plus or minus. Now, those aren't actual x-intercepts that you are going to see. They are imaginary. They're in a different dimension, right? But they are solutions to this equation. They are technically x-intercepts, just in a different dimension. Thought I'd throw that one at you again, because I think the delta has a few like that, which is what I would like you to go do now. You have a delta assignment that has a couple factoring with GCFs, and a couple factor by grouping, just like this one here. So hopefully that was making some sense. If not, you can watch the delta videos, and hopefully a different perspective there will help you out. So head on over to Delta Math and try that assignment out. Goodbye, everyone.